Welcome to NASA STEM EPDC Quick Bits Science and Engineering Practices. NASA STEM Engagement and Educator Professional Development Collaborative provides NASA resources and STEM strategies for STEM engagement. In this series, we intend to reach educators, parents, and caregivers to quickly explain a specific big idea in STEM. We will introduce a NASA example of how this idea is applied in the real world. And finally, we will demonstrate step-by-step how to lead this activity at home or in the classroom with your students. You might invite your students to watch with you at that time. We invite you to join us as we learn more from our specialists. Let's get started.
Greetings. I'm Dr. Samuel Garcia Jr., Education Specialist at NASA's Kennedy Space Center. The main objective is constructing explanations and designing solutions. The name of today's activity is Down to the Core. In this activity, the student will participate in the following practices. Construct a scientific explanation based on valid and reliable evidence obtained from sources. Apply scientific ideas or principles to design, construct, and/or test an object, tool, process, or system. When NASA cannot send people to collect samples, they send spacecrafts with special tools that can collect these samples. To find water, interesting minerals, or even life, you have to dig into a planet, the moon, or an asteroid. The newest rover, Perseverance, will collect core samples from the Martian surface. This will help scientists learn more about the history of the planet and look for signs of ancient life. NASA explores space. Scientists study asteroids to learn more about the solar system when it formed millions of years ago. The OSIRIS-REx mission, which was launched in 2016, collected samples from an asteroid and will be returning them to Earth in 2023. Think about how you can become a NASA astronaut and how you can do research with these samples. In this activity, students will use the engineering design process to design, build, and test a device that can take a core sample from a potato or modeling clay. The first step is ask, identify and define the problem. The next step is to imagine, which means to brainstorm ideas and solutions. The next step is to plan, select and sketch a design. After you plan your design, you create or build a model or prototype. After building, you must test your design. Once you test it, you will improve your design. And finally, the last step is sharing the results of your design. The focus of this activity is to help students construct explanations using their understanding of scientific and engineering principles. We challenge you to design and build a tool that can collect a sample from the center of a potato. Suggested materials are as follows. To reduce food waste, we suggest you use modeling clay to do this activity. Identifying the problem and brainstorming. What would you use to insert the straw into the potato or the modeling clay? What kind of frame would you need to make to hold the rubber bands and the straw? Design and construction. Below you will find some ideas for your design. Come up with your own design or improve on any of these. Test, evaluation, and pre-design. If the straw breaks or bends, cut off the broken piece or use a new straw. To increase the force of the plunger, try adding more rubber bands. When you stretch the rubber bands, they accumulate potential energy. When you release the rubber bands, the potential energy changes to kinetic energy. When the straw hits the potato, the kinetic energy changes to mechanical energy and does work. Make detailed observations of your design. Write down your observations to explain the effectiveness of your design. You may consider recording your test using a cell phone or a video camera to observe and analyze your design processes. Try this. Come up with something easy to extract the sample from the straw. Transform your tool into a spaceship. Add rockets, stabilizers, solar panels, or other spacecraft components. Think about what you have learned in this activity. Do you think you can build a better design? What other materials can you use to design and build a better tool? Be sure to share your results with your friends and family.
Thanks for watching this NASA STEM EPDC Quick Bit. Don't forget to check out the description below for more information and links.